Welcome back, guys. This is lesson 5 and looking at the connections between the derivative and its function. Looking at the connections between the derivative and a function. So we know um, these basic characteristics that occur for a derivative in its function. So we're going to use those today. What I'm going to ask you to do maybe is to highlight. Well, I'm going to use highlighters. You can choose to use them as well, right? But I'm going to use highlighters, and I'm going to turn my Wi-Fi off so it doesn't get interrupted today. Okay, so the first thing I'm going to look at, I'm given this graph of f prime of x. This is my derivative, right? I'm going to use it to sketch a picture of the function for this derivative. So first I'm going to look at the zeros, because this is going to tell me that there's a relative minimum or maximum at these zeros, these x-intercepts. So here is the x-intercept for f prime of x. So f prime of x has zeros at -2, where x equals, make this smaller, equals curly bracket, -2, comma, looks like 2. All right. That tells me that I have a relative maximum or a relative minimum at that point. I don't know yet. So one of the next things, I'm going to get my maximums and mins for f of x from right here. So a relative, and we want to be sure we use that information, right, that word, relative maximum or minimum. We don't know yet. All right, so I'm going to go mark this place right here. So there's a maximum or a minimum right there. There's a maximum or a minimum right there. Now I'm going to go highlight where the y values are less than 0. So I'm going to go highlight where the y values are less than 0. So I'm going to highlight that pink. So all of the y values on the derivative are less than 0 from here all the way over to 2. So from -2 to 2. So I'm going to write that interval down. So on the interval, and we're talking about x values, the domain here, on the interval, and it's from -2 all the way over to 2. And I'm actually going to do parentheses there because we don't want to do equal to. Okay. Now, this is where I can get my intervals of decrease. I can get my intervals of decrease. So it says when f of x is less than 0, this function is decreasing. The function is decreasing. So from -2 to 2, this function should be decreasing. So this is interesting. All right. So next I'm going to highlight where the function is, the y values are above the x-axis. So here and here. So if I were going to collect those intervals, I would have from -infinity over to -2 union, from 2 to +infinity. Now, changes from positive to negative. Where does it change from positive to negative? So positive to negative, this is going to be from positive to negative, like my y values. The y values change from positive to negative right here after they pass -2. So at -2, okay? Changes from negative, the y values change from negative to positive, and this will help me be more specific. At x equals, I should have said x equals -2, and x equals 2. Okay? So let's go back up and look here. It says when f prime of x changes from positive to negative, a relative maximum exists. So a relative maximum exists. So positive to negative, that means I have a maximum. This is a maximum. At x equals -2. This is a maximum. Not just any maximum, a relative maximum. When it changes from negative to positive, I have a relative minimum at x equals, let's see, we have 2. Okay. So I don't know what y value would be, but it would be something like let's just say we have a relative maximum. So this can be our maximum. And just for emphasis, this could be our minimum. Okay? Now, since I have a maximum there, that means when I sketch this, and I'm just going to be a sketch, guys. So I'm going to do like some sketch here. I'm just going to be a sketch. So it should look something like this. Goes down, comes back up. Because we have a maximum here, and we have a minimum here. Okay? Anyways, so my relative maximum is at x equals -2. Relative minimum, I don't know what the y value is at x equals 2. Intervals of increase would be from -infinity to -2. And why? How do I know that? It's because all of the y values for f prime of x are greater than 0. Union 2 to infinity. And if I look at my map here, this is exactly what I have. Intervals of decrease, it directly comes from here. So this is my decreasing interval. This is my increasing interval. So it will be -2, 2. And let's see if we got everything. Yes, we do. And I have on this derivatives map, I have a 0. I have a minimum. At, let's see, 0, -4. And that does nothing for me. So we're going to practice doing this today as we move forward. So using f of x to learn about f prime of x. So those same rules apply. So when it tells you to approximate the value of f prime of 4, one, if it's a minimum or a maximum, if it's a minimum or a max on f of x, then f prime of x is going to be 0. So here 0, here, 0, here, 0. So I have f, this is f of x, this is given f of x. But if not, if I can't do that, then I could use, just get the slope. So just basically saying that we'll use that mean value theorem from like lesson 1, which just basically says f of um, f of x minus f of a um, divided by, just like using a slope formula here. This is a slope formula. So I'm going to find where x equals 4 on f of x. Okay, I'm going to go up, and it's right here. So what I would do is, what you do for this is you used the interval, the x value before 4 and the x value after 4. So we look from 3 to 5, and I get those y values. At 3, we have 0. So we have 3, 0. And at 5, we have 4. And I use that to approximate f of 4, because this is my x1, this is my y1, this is my x2, this is my y2. If we were referring to this theorem that I just brought up right here, this would be x, this is f of x, this would be a, and this would be f of a, or interchangeably, it doesn't really matter. So you understand that we're basically using the slope formula to find derivatives at a point. So guesstimating f of 4, we have 4 minus 0 over 5 minus 3, or interchangeably, it doesn't really matter. And I get that f prime of 4, this derivative, equals 4 over 2, or just 2. So here's my answer. That's my approximation that this slope at this point for f prime of 4 is 2. At what values is f prime of x 0? This is when f of x has a relative max or minimum. So relative max right here. So we can say when x is negative 3, right here when x is 1, and right here when x is 5. Okay? And that's my justification. What open interval is f of x less than 0? So when f of x, f prime of x less than 0, when f of x is decreasing, f prime of x is less than 0. So when it's decreasing, f prime of x is below the y-axis. So let's go find where it's decreasing. It's decreasing from negative 3 all the way over to 1. So remember parentheses here. From negative 3 to 1, union. When is f of x decreasing? From 5 to positive infinity. What open interval is f prime of x greater than 0? When f of x is increasing, f prime of x is greater than 0. So intervals where it's increasing, right here, here, and that's it. So from negative infinity over to -3, union, and from 1 over to 5. Okay? Says picture below is the graph of f prime of x. This is f prime of x. All right? On which open intervals is f of x increasing? So that's when f prime of x is greater than 0. So it looks like, wow, interesting. So if this is the x-axis, here's my x-axis, okay? And the only place where that could occur is right here. The only place where that could occur is from negative infinity so since f prime of x is greater than 0, all the y values are greater than 0 right here only, from looks like 3 to -2. It could be infinity, but I doubt that because it's a piecewise function. So we'll just say -3 to -2. Then the function f of x is increasing on -3, -2. On which open interval is f of x decreasing? So that's where all the y values are below the x-axis. So because of this right here, it's not differentiable right here because it's like a corner and it's a piece, it's like it's a piecewise function. So we're gonna do this with a union. It says on which open interval is f of x decreasing. So from -2 to 2, union 2, oh, that's a 0. That's 0, sorry. -2 to 0, and 0 to 4. Because f prime of x, all of the y values are less than 0. This is shorthand for saying all y values of this derivative are less than 0. So that what values of x does f of x have a horizontal tangent? Well, that's an easy one. That's an easy one. Um, it's gonna be, that's a tricky one as well because it's gonna be this whole line right here. Um, and it's gonna be from -3 to -2. Oh, my bad. That's a tricky one, but you'll see that later on. But for sure, at relative maximums and minimums, f of f prime of x equals 0. So at relative maximums and minimums, f prime of x equals 0. So where can I find um, relative maximums and minimums? You look at the x-axis and you find the places where the derivative has a 0. So it has a derivative 0 right here, and it has a 0 right here. And at relative maximums and minimums, f of x has a horizontal tangent. Just the facts. So these are my justifications. Therefore, x equals -2 and x equals 2 would be the places where I would have a horizontal tangent. It says, what is the slope of the tangent line to the graph of f of x at x equals -1? What is the slope? So all I need to do is go find f prime of -1 on the graph. So I'll go to -1, and it is equal to -1. That's the slope. What is the slope of a normal line to the graph of f of x at x equals 4? So that's going to be, remember, the normal line is perpendicular to the tangent line's slope. So this is the tangent line slope. Normal line is perpendicular. So slope perpendicular is going to be 1 over that tangent line's slope. And this is the correct notation. So 1 over, let's go find 4. It's right here, and we have -2. So the slope is -1/2. Pretty straightforward. I'm going to end it right there. We're going to move on to analytical connections next.